Right, so looking at question 2.2, everyone can see my screen, right? Okay.
Yes, ma'am.
Brilliant. Now, very important. Okay, so this wasn't exactly a good paper. So they included things that were not necessary in answering the question. So looking at 2.2, they gave you the point R, which is -3, K, and S, 2 and -3. These are points on a Cartesian plane. Determine the values of K if RS, the distance, okay, so the distance RS is equal to 5√2. What we're going to do at this point, we obviously want to make K the subject of the formula. So we're going to use our distance formula and plug in these values. Okay, so x1 minus x2. Take your -3 minus 2. That's the first thing you're plugging in. And then the second y values. That's your K minus your -3. And you square that. Okay. 5√2 is equal to that. So -5 squared, you will have 25 at that point. Now, a negative and negative this point, remember those two will become positive. So you have K plus 3 in brackets squared at this point. So we now want to expand that. Okay, you keep your 25 there, ends up as K squared plus 6K plus 9. Okay. Group your like terms. K squared plus 6K plus 34. Now, you still have your square root signs, but we need to get rid of those. So that means what you do to the left-hand side, you're going to square there. You do exactly the same thing to the right-hand side. So you end up with 50, because 5√2 squared gives you 50 here, and K squared plus 6K plus 34. Okay. Any questions so far? Okay. Balancing method, bring that over, group your like terms. You are left with -16 here. Now, if you're at this point and you can't see the factors straight away, you can just plug them into your quadratic formula. But the factors of -16, okay, those would be +8 and -2. So your possible values of K is equal to -8 or K is equal to 2. All right. Okay, so that's everything from Yonila's first question. Just checking if she's back. If she's not back, I think we're just going to go into Taha's question. Is Yonila back? Can you guys see her in the chat? No, okay. Let's go into Taha's question.
Ma'am, I also sent you a question on the trig.
Oh yes, I saw it, my darling. We'll do it as well. Okay. I'm not sure if you guys can see this clearly. Do you want me to zoom in? Okay, let me do that. So this is from the 2020 paper, okay? Taha, I think you were particularly concerned about this question here, the touching internally part, okay? So I don't think you really need to worry much about this question, but we'll do everything else. I'll explain it as well, but yeah, not really needed for Monday, okay? So question 4, M -3, 4, that is the center of the large circle and a point on the small circle having center 0, 0. From N -11P, a tangent is drawn to touch the large circle at point T, with NT being parallel to the y-axis. NM is a tangent to the small circle at M, with MOS being a diameter. So first things first, determine the equation of the small circle. Okay, so if your circle is centered about the origin, right? So Remember, general equation of a circle, x minus a squared plus y minus b squared is equal to r squared. If it's centered at the circle, it's just going to be x squared plus y squared. So for doing that part, you're going to get a mark. Okay, what we now need to figure out is r, the radius here. Now, look at this point, okay? We can find the radius by using Pythagoras, but we also know by now that if you have a 3, 4 there, that means this is a Pythagorean triple. So your radius would then be equal to what? Who knows? Just by looking at it, what would your radius be equal to?
5.
Brilliant. So r is equal to 5. Why? Because of Pythagoras. Okay, so you don't even need to show all you're working, you just say r is equal to 5. So when you plug it in now, it's going to be x squared plus y squared is equal to 25. Okay, so mark for the 25 there. So that's where your 2 marks come from. Okay, so on to 4.2. Determine the equation of the circle centered at M in this form as well. Okay, so for this second circle, okay, let me get rid of that. Something important here, okay? So the nice thing about this one, we can also work out the left-hand side straight away, okay? So using the same formula, x minus 3, that gives you positive. So you'll have x plus 3 squared there, plus your y minus 4, because they've given us the center squared. All we now need to work out is the radius. Okay, so again, same thing. You get a mark for figuring out this first part here. Now, the other 2 marks come from working out what r is. So remember, the point T here, you have a tangent. So Tn is a tangent. If you have a tangent, okay, and you have a radius, okay, what do we know about the tan and the radius?
They're perpendicular.
Perfect. So you have a 90-degree angle there. Now, if they're perpendicular, remember Tn was parallel to what? To the y-axis. So if it's perpendicular, what can we deduce about one of the coordinates? What can you deduce about one of the coordinates?
Would the y values be the same for M and T?
Perfect. Thank you, Jack. So y is going to be the same. So here at this point, y stays the same, right? Now, what do you think the x coordinate is going to be for t, for that coordinate?
In negative 11?
Perfect. So if it's negative 11, what is the distance, right? From negative 11 to negative 3?
Plus 8.
Right, perfect. So the distance from T to M, okay, if you need to show you're working, you just say minus 3 minus 11, okay, and it gives us 8, okay. So 2 marks there. So your equation, x plus 3 squared plus y minus 4 squared is equal to 64, okay. Any questions so far? We remember we use the tan perpendicular to radius. You don't explicitly need to state it, but if you do use it at some point, write tan perpendicular to radius. Okay, so it's always safer to put whatever reason you use at some point, okay, just to be on the safe side. But here your mark allocation came from the working out the radius, okay, like that. Right, so that part is done. 4.3, determine the equation NM, okay, in the form y equals mx plus c. Now, we don't have a value for p here, right? But we do have the center here, which is 0, 0, okay? And remember, NM was what? It was a tangent as well, right? So that means you have 90 degrees here. Okay, so again, you have tan perpendicular to radius, it's 90 degrees. So what can you deduce about the gradients of OM and NM?
Ma'am,
Yes.
Can you go a bit slower? Just a bit slower.
Okay, sweetie, no problem. Okay, so let me just erase this other stuff. Okay, so remember the tangent, they told us that you have a tangent at the point M here. The line NM is a tangent, okay, to the circle centered at the origin here, okay? So if you have a tangent and you have a radius, again here, you're also going to have what? Your 90 degrees, your tan perpendicular to radius, okay? So based on that 90-degree angle there, what can you deduce about the gradients of NM and MO? Okay, so we can find the gradient.
One.
Yes, if you multiply them together, you get -1. Brilliant. So we don't have P here, but we can find the gradient by working out the gradient of OM. Okay, so let us plug it into our formula. So y2 minus 1, y1, x2 minus x1. Okay, so this would be your x1, y1. Okay, x2, y2. Let's plug it in. So 4 minus 0 divided by -3 minus 0. So your gradient is -4/3, like that, of OM. So what would your gradient of NM be? So gradient of NM,
3/4.
perfect, because it is the negative reciprocal. Brilliant. So
Ma'am,
yes.
because I really didn't understand the way you found it. Couldn't we have used the origin and the M, that gradient, and then find the gradient like that, and then just couldn't we have done that? And
Yes.
then we just okay.
Yeah, so that's exactly what I did. I just didn't put the 4 minus 0, because remember, this is the origin. This is exactly what you're saying, right? So 4 minus 0, okay, and then your -3 minus 0. It does give us the -4/3, okay? So that's the gradient from O to M. Then to get the gradient from N to M, it's just the negative reciprocal. That's why we end up with 3/4 there, okay? So your 2 marks there. So far, what you can write is y equals 3/4 x plus c. How are we going to work out what c is? Okay. Any ideas? How should we work out what c is?
Can you sub in M?
Perfect. So we're going to sub in m. Okay. So sub, what was that point? -3, 4. Okay. So that's your x, that's your y. So 4 equals 3/4. Your x is -3 plus c. Okay. Right, -9/4. So your c value ends up as what? What's your c value here? I get 25/4. Okay. What do you guys get?
I got the same.
Same.
Okay, so your equation is therefore 3/4 x plus 25/4. Some people also like to write it as 0.75 x plus your 6.25. Okay, either, it doesn't matter. Okay, all right. Now, let's see, what's the next question? Calculate the length of SN. Okay, let's go see where S is. Okay, so looking at this point here, S. Okay, so let's examine our diagram, right? This point here, 0, 0, what can that be? That is actually a midpoint, right? So if that's a midpoint, okay, we need to find what these values are, x2 and y2.
Ma'am, how do we know that O is a midpoint?
Remember, this is a circle, right? And the circle is centered at O. So the distance from O to M, okay, that's a radius.
The radius.
Right.
Yeah.
So this side is also a radius. Those two distances are the same. So it's a midpoint. Okay, good question. Right, I want to work on this side. I'm just going to erase this. Okay, so based on that, we're going to use the midpoint theorem, okay, and just plug in and use your inverse operations. So you have your xm, ym, right? So x1 plus x2 divided by 2, then y1 plus y2 divided by 2, okay? Now remember the actual midpoints for both of these were equal to 0. So 0 equals x1, let us use -3, right? Plus your x2 divided by 2. You want to cross multiply. 2 times 0 is 0. So 0 equals -3 plus x2. So what's your x2 value? Here it is 3. So this is 3. Okay. Now we need to find the y2 value. Again, since the midpoint was 0, 0 equals 4 plus y2 divided by 2. Cross multiply again. 2 times 0, you get 0. 4 plus y2. Make y2 the subject of the formula. Y2 is equal to -4. So, yes.
Would you have to do all this working out, because can't you just do it by inspection?
You can do it by inspection.
Okay.
Yeah, you can. I'm just doing it so everyone sees how we got there. Okay, cool. So, all right, so that was, yeah, so now length, okay, we know how to work with length, right? So the distance from S to N, right, is okay, and so from S to N, we need to find what that p-value is. Okay, so how do we work out what the p-value is before we carry on?
Don't we
Plug
sub
it
it
into the
in?
equation.
Brilliant. Okay, so we're going to sub in into the equation. So sub what? We're going to sub x is equal to -11 into which equation? Into y equals 3/4x plus 25/4. Okay, when you do that, okay, the corresponding y value is -2. Do you guys get -2 as well?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, so now we have the point. Sorry, 3 and -4 and -11 and -2, right? So we're gonna plug those into, so x1 minus x2 squared plus y1 minus y2 squared. Okay, so it's up to you which one you name, x1, y1, x2, y2. All right, so -11 minus 3 squared plus your -2 minus, so you end up with a plus there, right? And that's squared. Okay, so plug it into your calculator. What do you guys get? So -11 minus 3, and I square that, I get 196, okay? Then -2 plus 4, so 2 squared, that's 4. The square root of 200, and I get 10√2. What do you guys get?
Also
So-
about that.
Okay, cool. Right, so, right now, okay, so I said before, this last part, I wouldn't spend too much time on it, right? I'll explain it, but you don't really need it for Monday, okay? So the question was, if another circle with center B -2, 5 and radius K touches the circle centered at M, determine the values of K correct to 1 decimal place, and it's 5 marks. Okay, do you guys want us to do it or no? I can do it if you want to.
No.
Okay, so it's not needed for Monday, but obviously for your final exam, yes, you're going to need to know how to do this. So I think it would be more beneficial for us to do something that will really help for Monday. So it's up to you guys. Yes, no?
That's cool with me.
No.
I
Okay,
mean, not in the paper, it's fine, man.
Okay, cool. All right. So Yonela's other question. All right, it was this one. Okay, so in the diagram below, you have points P, 5 and 13, Q, -1, 5, S is 7,5 and 8. They're given. SR is parallel to PQ, where R is y-intercept of SR. The x-intercept of SR is B. Okay, and then QR is joined, right? Determine the gradient of PQ. So by now we should all literally know how to do gradient, okay? So from P to Q, we do that gradient. So MPQ. So Y2 minus Y1, X2 minus X1, okay? 13 minus 5 and 5 minus -1, which ends up as positive. Okay, what do you guys get here? So,
4/3.
okay, yeah. So it's 8/6, which gives us 4/3. Okay, there's about 2 marks for a question like this. Calculate the length of PQ. Again, it's just distance formula, right? So the distance from P to Q, again, straightforward plugging in. Okay, so x1 minus x2 squared plus y1 minus y2 squared. -1 minus 5 squared. 5 minus 13 squared. Okay, and we all know the square root of 100 is 10. Okay, then determine the equation of the line RS, okay, in the form AX plus BY plus C. Okay, now what do we know? We worked out PQ, right? And this gradient here was 4/3. So SR, okay, they also told us, remember up here, SR is parallel to PQ. So what would the equation, the gradient for SR be as well? It would also be perfect, also 4/3, right? Okay, so we, knowing that the gradient is the same, 4/3 x plus c. What can we do next? We can sub in the point S, okay? 7,5, 8. Does everyone agree?
Yes, ma'am.
Okay, so 8 equals 4/3. Your x value was 7,5 plus your c. Okay, you want to make c the subject of the formula here. What do you guys get? I get -2.
Yes, ma'am.
Okay, so y equals 4/3 x minus 2. Okay, right. So we're not done. Important, they want us to write it in this form. AX plus BY plus C, right? So let us first get rid of the denominator. If everything is being, well, if this is being divided by 3, what should we do to the entire equation to get rid of division by 3? Multiply. Right, so we're going to multiply the entire thing by 3. So 3y is equal to 4x minus 6. Okay, almost there. We're going to take the 4x and the negative 6 over. Okay, so negative 4x plus 3y plus 6 is equal to 0. Now we have got it in the form that they were requesting. All right. Okay. So we're going to need this equation at some point. Okay. So I'm going to keep it there. Okay. So now determine the coordinates of B. Okay. Coordinates of B at this particular point. What do you know about B?
X-intercept.
Okay, it's an x-intercept. That means the y value is going to be 0, right? So if the y value is 0, we can work out what the corresponding x value is by substituting in y is equal to 0 into this equation. Okay, so 0 equals 4 over 3x minus 2. 2 equals 4 over 3x. Multiply both sides by 3 over 4. I get x is equal to 3 over 2 or 1, 5. Okay, so the coordinates of B are 1, 5 and 0. Okay, so we've got 10 minutes left. Now calculate the size of ORB. Okay, now we're going to have to zoom into this one and see what they're looking for. ORB. So it's this right angle triangle here. Okay, we're going to find this angle of inclination. It's going to give us the vertically opposite one here. Okay, then we know that that's 90 degrees. Then we'll be able to deduce what R is. Okay, so remember, we're still working with this. So M equals tan alpha. M is 4 over 3 equals tan alpha. So inverse tan both sides. When you inverse tan both sides with your 4 over 3 there, alpha is equal to 53,13 degrees. Okay. That means the angle OBR, which is this little angle here, okay, the one I'm pointing to now, okay, that's also going to be 53,13, and the reason we use there is vert op angles equal. All right. Now, from there, since I've just worked out that vertically opposite angle, I'm going to use sum of angles in a triangle to work out what ORB is equal to. So ORB, 180 minus 90 minus your 53,13. The reason, sum of angles in triangle. So ORB is equal to 36,87 degrees.
Ma'am, in a question like this,
Hmm.
do you need to state that BOR is 90 if it's given like this?
Well, so you need to, so what would you do? Would you go straight to the answer 36,87 degrees?
No, I would still go ORB equals 180 minus 90 minus 53, but do I need to state why or how I got to the 90?
No, you don't.
Okay. Thanks,
Okay,
ma'am.
okay. So the only reasons you need here, vertically opposite angles and then sum of angles in a triangle. Okay, then
Thanks, ma'am.
sure, prove that QBSP is a parallelogram. So QB, so that, and then SP is a parallelogram. What can I do? So far we know that that side is parallel to that side, it was given, and we worked out, or we know that those are the same gradient. What can I do to prove then that QBSP is a parallelogram? What else can I do here?
Distance.
Okay, but what else?
You prove that the other lines
They're
are parallel.
equal.
Okay, equal, yes, but the simplest one. What's the simplest thing that we can do to prove it's a parallelogram?
Ma'am, you can find out the gradients of QB and PS.
Perfect, right? So choose the easiest path, okay? And that's just showing that the two gradients are the same, okay? So let's work out the gradient MQB, okay, and gradient MPS, okay? Then if you show that they're equal, then it's a parallelogram. Okay, that's all you have to do for this one. Okay, so is it necessary for us to do that? Because I think we've done lots of gradient questions.
That's cool, ma'am.
Okay, so, oh, I forgot to download someone's question, but I think I'll just have to write it out. Okay, so we've got 5 minutes. I'm hoping in the 5 minutes we can get one question in. It's on trig, the reduction type question. Let me see if I can. Okay, so 520. Okay, so it was this question. So sine 2x cos negative x plus cos 2x sine 360 degrees minus x. Okay, this is all divided by sine 180 degrees plus x. Now this question wants us to determine, without using a calculator, the value of this following trigonometric expression. So what I see here is there's going to be lots of reduction, right? Let's go ahead and reduce. Okay, so starting with this one. Okay, so whenever you see a negative angle, what are you meant to do? You can add 360. So once you add 360 to this, you end up with cos 360 degrees minus x. Now, which quadrant are you in at that point?
Fourth.
The fourth quadrant. What do we know about cos in the fourth quadrant? It's going to be positive.
Positive.
Right, so all you have to reduce it to is just cos x. Then sine 360 degrees minus x. What do we know about sine at that point? It's going to be negative sine x. Okay, at the bottom, sine 180 plus sine x. Okay, again there, it's in the third quadrant, so sine in the third quadrant is negative. So for doing those three, this is a mark for that, a mark for that, and a mark for that. Now, next step, okay? Remember, this is multiplication. We're not subtracting that, it's still multiplication. So what you have now is sine 2x cos x minus cos 2x sine x, okay? This is all divided by negative sine x. Now, looking at your numerator, it looks like a compound angle, doesn't it? Can you guys see that or no? Okay, so what I'm referring to is this, sine A minus B equals, okay, if you expand that, you end up with sine A, and then what? What's the expansion? So if you get stuck, right, it's on your formula sheet. Sine A minus B is sine A cos B minus cos A sine B. Okay, so that's what we have here. Okay, so using that, I can reduce it or make it smaller, and it ends up as sine 2x, because that's the A, okay, minus your B, which is the X. Now, if it's in brackets like that, so this was your A, this was your B, that's your A, that's your B. Now, this is A minus B here. Since it's in brackets, you can simplify that, and this will become sine X at the top and negative sine X at the bottom. So your final answer is just -1. Okay. So
Ma'am,
yes, darling, ask.
can you explain how you got from, when you wrote in black, it says minus sine x, and then in the red, it's positive.
Okay, so remember at this point, I said we're multiplying, right? So if I multiply positive 1 cos 2x multiplied by negative sine x, a positive and a negative, okay, will give me a negative. So that's how I got to that, because of the positive and negative, okay?
Okay.
All
thank you.
right, perfect, okay?